Mother's Day is coming up quick. My mom is pretty difficult to shop for, so I thought I'd make her something this year instead. I recently saw some really cool 7-color e-ink displays posted by Owen Williams on Twitter and agreed they would make a great, unique photo display. I got the 4-inch screen, which I think will be a nice size for a desk ornament. I'd also like it to support both landscape and portrait photos, so I'm going to put a servo in its base and rotate the frame based on the image being shown. There's only one literal moving part in this project, but lots of figurative ones, so let's get started. This technology is called ACEP, or maybe ACEP, Advanced Color E-Paper, and these panels only became available to consumers within the last couple years. I've got a Raspberry Pi Zero mounted on the back of the screen and some basic Python code controlling it. I'm going to run the script and start a stopwatch, because this does take a bit. The script takes a few seconds to get started, but once it gets going, you'll see the new image flash in and out a little bit. After that, the whole screen flashes mostly black and yellow though. The whole refresh process takes around 30 seconds. Near the end, you start to see the new image flashing in and out again, and then it sticks. After that, even if the system is fully powered off, the image will stay on the screen indefinitely. Since the refresh rate is so slow, I'm only going to make it change photos automatically every hour or so. There are also some buttons along the top edge of the display board that I'll be taking advantage of for additional features. Honestly, the code I put together to control this is pretty messy, but it gets the job done, and it's simple enough that I'm not going to bother refactoring it. When the system boots up, it schedules a repeating task to display a random image every hour. To do that, first it makes a list of every image in the folder and picks one at random. Fun fact, I was feeling lazy and mostly got ChatGPT to write this function for me. Once it has a random image, it just displays it on the screen. This function is gross and does a bunch of stuff. It adds the current image to an undo buffer, rotates the new image based on its EXIF data or an educated guess, and then sends it to display using the Pimoroni Inky library. Other than that, the only things to note are the button handlers I mentioned earlier. One button advances to a new random image immediately, another acts as a go back button, and the third can be pressed and held to make the system power off. You'll note the load-bearing print calls in these functions. There's some kind of issue with the display draw calls blocking or not blocking other I/O in somewhat inconsistent ways. I didn't get time to dig into this more, and it seems to work fine like this. Really, it's the kind of bug that only hurts your pride. The modeling for this project went really well, though I guess it's easy to say that before you've actually run the prints. Here you can see my original paper sketch that I brought into Fusion for reference. The end result looks pretty close to what I'd initially pictured. One thing I'm really happy with is this rear access plate. I typically use embedded nuts to secure plates like this, but I wanted to try the remote control style latching cover instead. I printed up small test sections to make sure it actually worked, and it's a great fit. It's easy to insert and remove, but holds in place really well. This is also the first time I tried joints in Fusion. I can already tell I should have tried them a long time ago. They're awesome. I was able to easily set up positioning constraints for the motor joint, which gives me an accurate view into the table clearance for the frame. Now, I could just print this frame, but this is a gift. It has to have a little extra polish, you know, so I bought a CNC router. I'm down in the basement, and the CNC router is going to go behind me. Now, I looked for a workbench or table to put in this space, but it would have cost at least $300 or $400. Instead, I got some sealant, 2x3s, and a sheet of plywood. They cut the plywood to size for me for free at the hardware store. I'm going to sand and seal this board with some polyurethane and mount it using the 2x3s. Then, I can actually assemble the CNC router. You might be thinking, it seems like a really bad idea to do that standing inside, and well, you'd be right. I pretty much instantly regretted this and put a mask on. The vacuum and dust and cleanup was also a nightmare. Next time, just wait for the rain to stop. Okay, on with the build montage. millwright came with some basic clamps, but I don't think they'd work very well for how I have to hold the frame. So I looked around a bit and found an eccentric clamp design by Marius Hornberger that seemed pretty smart. It was easy to model my own version of them. Then I used the Fusion manufacturer workspace to lay the parts flat and make some copies. I set up 4 machining paths. First, a countersink with a 90-degree bit, then drilling with an 1/8" bit, boring with the 1/4" end mill. You can see it's got a little tiny helical pattern in there. Hopefully that works all right. And then cutting out the main contours. Again, this is with the 1/4" end mill. This was my first time using Fusion's CAM tools, and I'm really impressed with how powerful and straightforward they are. I just watched their video tutorial series and was able to mostly figure it out from there. At least, I think I figured it out. I've got some wood set up on the CNC, and I've exported all the G-code from Fusion. I've done a bunch of tests while setting up the machine and learning about Fusion's CAM tools, but this will be the first time I'm actually attempting a cut operation. Let's see how many bits I break. The first print's done, and the first cut's done, and it went really well. No crashing and no bits broken. The parts also seem really consistent with each other. Unfortunately, the dimensions are off to the point where the cams won't actually fit in these base plates. Just too big. So I ran some quick calibration cuts to dial in steps per millimeter, then cut these new cams. The hole size on these blocks was close enough the first time around, and the new cams fit great. This is the finished product. It seems to be working well, and I'm really thrilled with how this frame came out for our first CNC project. Thanks for watching, and don't forget Mother's Day is May 14th. Made this for my mother-in-law over the weekend as well. It's just engraved with a 60-degree V-bit. The CNC stuff is going to be pretty fun, I think.